Hello calculus students, and welcome to the continuing video on the chain rule, or the methods for taking the derivative of a composite function. So in the last video I did a proof of this, and the proof is good to see where it comes from, just so that you're not totally mystified by this, but we're going to focus more on the applications of this. So the chain rule really just says that if you have a function that is a composite, f of g of x, and you want to take the derivative of that function, then what you want to do is take the derivative of the outside function, f, with respect to the inside here. So g here is really the entire function g is really the input of f. Then you take the derivative of the inside function and multiply those two together. In Leibniz notation, it's dy over dx equals dy over du times du over dx. You can kind of see that the fractions work out, the du's cancel, and you end up with dy over dx. That's technically not mathematically correct, so I'm not going to write it down and cross stuff off, but it's a good way to think of that, to think of it when it comes to taking an exam or solving some basic problems. Okay. So let's get right to it and do a couple of examples here where we have to use the chain rule. So in the first example here, we have f of x equals 2 minus 3x to the third quantity squared. Now I'm aware that you could just FOIL this out and take that derivative, but that's going to be a little bit tedious in many cases, and it's going to be really tedious when the inside term here, the inside function here, has more than two terms, like 3 or 4 terms. Okay. So you can think of it this way, as that there's two functions. You can think of this as g of x is, let's call that the outside function, that's x squared, and let's call this h of x is the inside function, that's 2 minus 3x to the third. So f here in this case is really saying g of x, that's x squared, and take h of x and put that into it. Okay. So we're basically breaking this composite function down into its components. H is this part that's on the inside, and g is the part that's on the outside here, essentially in the parentheses. Okay. And so now we're ready to take the derivative. Let's take the derivative of the outside function, which is just x squared. So you get 2. It's just 2x, right? But the input is 2 minus 3x cubed. Okay. Then multiply that by the derivative of the inside function, which is just negative 9x squared. And then we can, I should appropriately label this f prime. And then we could simplify this just by multiplying some of the terms together. Negative 18x squared times 2 minus 3x to the third. If you're taking the AP exam, you might be asked to multiply this out, or you might be asked to factor out a -1 out of this. But this is an acceptable final answer. If you're not taking the AP exam, this is definitely an acceptable final answer. In some of the more complicated scenarios, you might have to do some more factoring. But I'm going to end this simple example right there. Okay. Let's take a look at the next one. Now you have g of x equals 15 over 1 plus 3x squared. And this is one of those scenarios where it's probably simpler if we alter the function a little bit. Okay, we could use the quotient rule to solve this problem, but this way I think is the simplest, less messy, less error-prone way. So now we want to take the derivative of the, this is the input here, that's the inside function. X to the -2 is the outside function. So now we want to take the derivative of the outside function, so we get negative 30, leaving the inside function exactly the same, to the -3rd power. Then you got to multiply it by the derivative of the inside function, which in this case is just 3. Okay. And then now here's where some simplifying will come in. This becomes negative 91 plus 3x to the -3rd, which is equal to negative 90 over 1 plus 3x cubed. For those of you who's taken the exam, this is the version that you're most likely to see. If you're not taking the exam, this is the version that it needs to be in. It's the most standard, widely accepted representation of this. Okay. So there it is, a couple simple examples regarding the chain rule. I'm going to end this video here and start another one where we deal with some of the more complicated examples and simplifying becomes a real big issue. Thank you for watching and have a wonderful day.